Here's the PCB ready and complete. And if you remember when we decided that this is the only possible location for the band selector to be installed in this specific location, I said we are going to pay the price, and that is how we pay the price. You see the jumpers here and here. So the wiring is not that fancy at all. As you can see, also we put some wires. Actually, we substituted wires from here and here and correct some of the PCB wiring. But the wires are correct and it is perfectly working, and that is actually what matters. Okay, that was our only choice to put it in this specific location if we want to have all the components in one box. Remember, we were actually chasing the idea of a small size. Right now, this one is complete, so and it's working correctly and nicely. So let's just show the inputs and outputs of this PCB. We have here the power terminals, the ground, and the positive rail. Okay. This is the ground, and this is the positive rail. This is the output of audio of the circuit, of the radio. This is actually the input of the EMRF. And also this is the positive side, where we can connect one of the wires of the RF coil. Also, we will put the other wire here, okay, on this side. We have also the antenna from this side, and that's it. So we actually make holes for fixing screws. I have 4 fixing screws to hold it in place, and we installed it on the radio, and it was nice and smooth. But before we actually finished this PCB, actually we had a trouble when we discovered that the intermediate frequency coils, they are more high than the band selector. The band selector, actually, we had to do a surgical operation to shorten its height by opening it actually and filing a lot of its metal case so that it will be fitting inside the box. But unfortunately, when we installed the radio, when we installed the intermediate frequency coils, we discovered they are a little bit higher, which actually stops the box from closed. So we actually dig from the surface here for those two IFTs to lower the surface to enable them to fit in these, and by that we achieved closing. It's closed correctly and nicely. Okay, so and as you can see, of course, the PVC is hanged with the PCB, because it should be actually to the level of the PCB, you know. Otherwise, it will not allow the box to close. All right. So we have it will be installed like this. This side also, like this. Okay. It's fitting nicely and it's okay. So it's good to go. The only thing now left is to design the audio power amplifier. And as I told you before, we have designed first the radio circuit, because I know this will dictate to us how and where to install the audio circuit. So now, as you can see here, we have this new issue of those two IFTs. Okay, that's how we shall actually change everything here like this, because we have to cut now from this side, if you get me on that. And I don't think that we will be able to use anything from here, for example, for the power jack or something, because as you see, it's occupied. And we also will have the RF coil on this side. Okay. So we have to cut from this side also to allow for the IFT cans to fit in here. You see? So that's why I was advising you that not to fall in the trick of designing the PCB of the audio amplifier first. Otherwise, you will find yourself actually with a problem when you come to design the radio printed circuit board. So we designed the radio first, then now we will go ahead and design the audio power amplifier according to the facts that we already have with this PCB. Okay, here's it. I can admit that it takes so much time, but it's a design, my friends. The design needs certain protocols. So one of them that you spend enough time. And the other one is to start with large things first. I think I had a video about that. Maybe I'll put a link in the description. Make the designs correctly. So it will be fitting in this place. You see, it's fitting correctly. Now you got me when I told you that you have to start with the PCB of the radio first, so that the left space will dictate how you can make the audio amplifier. So otherwise, if we do the opposite, we'll be in trouble. So as you can see, this electrolytic is getting inside in space, and those filters will be actually running through here. Okay, also this capacitor will run from here, and the circuit or the IC will infiltrate in this place. Okay. This is where the lithium-ion battery is connected, and this is the power jack, power plug. In this circuit, it is actually used to charge the battery, lithium-ion, and it has a switch inside so that it will disconnect the circuit and the whole radio. Here you have the output. Power. Here we have the power on-off switch, which actually stops all the circuit, and we don't want this switch to stop the battery and stop the charge. So when the radio is on, all you have to do is to put the charging wire inside, and it will disconnect the radio, whether it is on or off, and connect the battery for charging. Okay, so that's actually one of the aspects which actually took so much time, and actually this one is this circuit has actually taken so much time, I have to say. So you see, when you put the circuit like this, it will disconnect the circuit and everything except the radio, whether or not this button is on or off. So here where I put the white dot, this is on, and it is easier. It will be like this. So as you have seen, we have utilized the back of the radio for the audio circuit, and we actually replaced the dry-cell battery with lithium-ion battery. We actually utilized this space to put the lithium-ion, and we have the on and off button. Whereas on the other side, the other half of the box, we utilized it for the circuit of the radio and the speaker. Okay, now this audio circuit is working, and even now if you want to charge it, it will be charged. Okay, but it's okay to test it for double checking only. Otherwise, I'm sure it's working, because before I install it here, it is actually, as you can see, fixed in using 3 small size screws. Okay, connected the circuit to an outside speaker, and this is our usual MP3 player. So, and this is on and off button. Okay, so let's open the MP3 player to see. This is good to double check before connect to the radio. Okay. Put it on. Now it is on. Actually, it is loud, very loud.
مرحبا. يعني على سبيل المثال لماذا لا يكون هناك معرض عالمي عن الملك عبد العزيز رحمه الله تفاعلي ويرى
Okay, here's the radio, and it is working with problems, serious problems. Okay, so as you can see, we have used this knob to help us for the variable capacitor for tuning, okay, into the broadcasts. But the problem is, you can see it is large. All right, before we go onto the problems and solving the how to solve these problems completely, we have to know that these problems would push us definitely to open it again and correct these problems. As I said, they are not easy problems. They are hard and serious problems. We're going to see them later, but before we do that, we have to do some technical steps. First off, we have to cover this speaker with two covers. The first one is the fabric cover that we will design for it. We will put it like this. Then another cover, which is for the upper cover, and that is to smooth out the audio coming from the speaker. Secondly, we have to do something about this knob here. As you can see, it is higher than the surface. I hope you can see that. See, there's a space here in between the knob and the surface. Secondly, it is large. It can protrude from here and from here too. So we should do some modification in this knob to make it lower, and to make it smaller in diameter, so that it will fit this radio. It is taken from a radio kit. Okay, so the first thing we're going to do is to solve this problem. But this is a design. As you know, my friends, the design is not an easy issue. Most of the times you are actually stopped. These problems are confronted as challenging problems, especially when you don't have tools. We don't have proper tools to do the modification on this knob. We want to lower it a little bit. So if you think, for example, we should fire a little bit from here, you are 100% mistaken, because this is not going to solve the problem. So we have to do the correct thing, and that is by taking the whole grip of the knob here and trying to cut it and put it a little bit inside. In other words, putting the knob a little bit down to the grip itself, so that it will be very near to the surface. Okay, number one. Number two, we should cut circularly in a very equalized and balanced way from the diameter of the of this knob. So we have to think. We don't have the suitable tools. So what to do? We have to be a little bit creative, my friends, and we have to come up with a solution. how we solved the problem of this knob by modifying it to the suitable size through cutting and filing and other actually steps and actions done in order to reach to this satisfactory result. As you can see, the distance between the knob and the radio is almost nothing, if you can see. This is the desirable distance that we really think of, and this is the desirable size that we were actually looking for. So part of it you have seen it through the videos, and part of it was off the camera. Now let's move to the problems associated with this radio. Unfortunately, we have some problems needs to be studied and solved. So for the EM, whether MW or shortwave, we have incorrect range shortage of the variable capacitor. I mean, the broadcasters and the frequencies are not correct, which is not can be solved by the normal calibration. Also, FM, there is a whistle if you increase the loudness, unfortunately, and also there is a distortion only for the FM. Now, we don't know for sure what exactly is the problem. It is because of the different in voltage and currents coming from the lithium-ion battery, but is it only restricted to the amplifier, the audio circuit, or it is also extended to the radio circuit? So this will take us a very long time in order to study it and define the problem exactly, then solve it with the correct solution. So for EM, for example, as you can see, it's okay, but it can be better than this. And there is something that's stopping it from being correct. Okay? So we need to solve this issue. For EM, for shortwave, is the shortwave, as you can see. The shortwave is restricted to this range from here to here. Otherwise, there is silence. Is it because of the variable capacitor? Of course not. But this happens actually after we apply the lithium-ion battery. See? Let's connect the outside antenna. You see this whistle? This is not from the radio itself. It is because of the problems I told you about. Okay. Now for the speaker, we still have to put a fabric cover here to prevent the dirt from getting in, and also we will put a speaker cover also to smooth out the audio coming from the speaker, because the noise is coming rough and need to be smooth, so that it's going to be smooth and easy to the ear by covering these holes, and also by making certain holes at the back, so that the audio from the or the sound coming from the speaker will travel in both sides and will create a very smooth and nice, acceptable to the ear, and easy and smooth sound. For the FM, as I said, there is a noise and there is a whistle also. You can see here, this is the FM. Okay, let's just increase the loudness a little bit. Let's put the antenna. I don't know if you heard that. See? It's okay when we lower down the volume, but when we increase the volume, there is a problem also. So we are going to actually search the reasons for. And we are going to solve it. Okay? Okay. Okay. We have solved the problems by correcting the voltage of the battery, or the lithium-ion battery, to resemble exactly the same like the dry cells. So this circuit regulated power regulator, along with a resistor of 33 ohms that has been installed here, will ensure that the battery to the radio will behave exactly like the dry cells. So once the battery is full of 4.1 volts, this power regulator will provide for the radio the 3.1 volts maximum. And once this dry cells goes down for discharging to reach to about 3.1 or 3 volts, it will provide, this circuit will provide to the radio circuit a 2.5 volts, which is the minimum that the dry cells can provide before the radio goes down. Now, this will ensure that the radio will consider this lithium-ion battery exactly the same as dry cells. Problem solved. Only one thing left, and that is the audio power amplifier. Okay? In this case, we have made some corrections to the radio, some modifications to help minimize or eliminate the possibility of interfering resonance or oscillation. And that's the whistle which we heard in the previous segment of this video on the bands. Okay, especially when you raise the volume up, and that is by increasing the capacitance here. If you look at the circuit, you'll find that here we have 103 coded ceramic filter, ceramic capacitor. We have increased this capacitance. I don't remember how much, but we increased by doubling. Sometimes triple capacitors are put in the same place to increase the capacitance, to eliminate any possibility for any resonance or reflected waves or any whistle can happen. By this way, we have solved the problem of the whistles that appear in the video completely and forever. Okay. In addition to putting another 1 microfarad electrolytic capacitor. Okay. All right. As for the correction of ranges for the bands, the EM bands, mainly I'm talking about the shortwave, we have actually replaced this capacitor here, ceramic capacitor, with another capacitor. Let's look at it on the circuit diagram. Here you can see that we have 10 picofarads capacitor connected in parallel with the coil of the oscillator of the shortwave. It was not enough, so we increased this to 150 picofarads, and that was coded by 151. Okay, with this we have solved the problem with shortwave, and the problem of medium wave was solved by proper positioning of the coil, of the RF coil, to reach the suitable and required range and inductance, in addition to minimizing the effect of lithium-ion battery, as I said before, to minimize it to the level of the dry cells. Also, we're using trimmers, of the EM trimmers. All right. We have FM now salt. We have shortwave salt. We have MW salt. Regarding the audio power amplifier, now that there will be no possibility anyway that any interfering signals would be outputted from this circuit, the TDA2003 integrated circuit wouldn't mind working with 3.7 or 4 volts, okay, in this circumstances, in this conditions, okay. So we are covered, okay, we're good to go. Okay, the last two things, the covering of the speaker and the antenna. The second one, I doubt so much I'll find it soon. I got to go to the electronics market to find the smallest one. As you can see, every milli is utilized and it is congested, and I don't find any place for anything to be put in there. Actually, it is very heavy. It becomes very heavy because it has been space utilized. So we have this female scarf cut, and this fabric is unbelievable. It is absolutely permeable to the ear, but can stop dirt from getting in. It is absolutely nice, and will be the best thing to be used for our radio, okay. Then I found this cover, which we can cut from anywhere, you see, by opening from this side. It will be opened. It's a little bit hard, but as I told you, it's gonna be nice with the dust preventer fabric underneath this metallic cover, okay. So this is one option. The other option is to use this one, which I found for an old Panasonic radio, okay. It is more light and more thinner, okay, and it has its own fabric. It is not with the same quality like that we have, but it is here. So I don't know which one of them we can use. The problem here is that the openings are not equal. You see it going down, going smaller and smaller, which is no good for such a design that we are having. It's not going to have an effect, but it's not going to be good as good as this, okay. So what do you think? I go with this because it is more thin and more easy to be managed.
اللقاء إلى كثيرا عاليهم ثياب سندس واستبرق وحلوا أساور
Too much interference, even here in the roof. You should be going outside because LED lamps are everywhere and they are the enemy of the radios.
احيانا في ناس يكونوا معك البيت، في نفس البيت، مثلا تكونوا تبغوا تطلعوا لمكان معين، تمام؟ وهذا الموضوع ما اخص فيه بنت او ولد، لانه في ممكن احيانا الان ناس يسمعوني يقولوا اي بس انت تقصد البنات. لا ما اقصد البنات. انا
I was thinking that I will take this radio for my camping and bushcrafts, but now I think I have changed my decision. See? There is no comparison. Smaller and multiband and louder. So this will be my company. It will accompany me to the outside camp, no doubt.